Welcome to the World Forum for Women in Science and Envisioning Tomorrow. We are now in the session for technical session, which is named Technology and Health, and I will let our moderator to begin the session.
Thank you, Tanya. Thank you for this starting talk. I'm Associate Professor Dr. Hind Jalaluddin. It's my honor to be a moderator of this technical session in this wonderful and prestigious conference, World Forum Women in Health 2024. Dear valuable participants, audience all over the world, welcome to World Forum Women in Science 2024. We are gathering to explore the intersection between technology and health in empowering women. It's a great pleasure that I extend my warmest greeting to each one of you joining us today. For digital health solution to advancements in medical research, our conference aims to showcase the latest development and foster meaningful discussion on how we can meet technology to empower health globally. I'm thrilled to see such a diverse and talented group of individuals coming together to share insights, exchanging ideas, and collaborate toward a common goal of empowering women's lives through a power of technology. Thank you for being a part of this important session, and I wish you a productive and inspiring conference experience. Let's start with the first speaker. I would like to introduce myself. I'm Associate Professor Dr. Hind Jalaluddin. I'm Program Director of Technology of Radiology Program, Applied Health Science Technology, Galala University at Egypt. Also, I'm a radio diagnosis consultant in Faculty of Medicine, Ain Shams University, Egypt. My passion is using a technology of radiology to address healthcare disparities for women. My innovation projects and efforts in empowering access to essential healthcare service and informations in fetal anomaly scan and fetal cardiac imaging is a main concern, with a newly introducing fetal cardiac MRI protocol as adjunct examination for fetal echo. My years of experience in general radiology and specialization in cardiovascular and fetal imaging as giving me passionate this topic and sharing and implementation of strategic plan in Galala University, as well membering in prestigious collaborations and as a responsible author of more than 20 international publication and eminent speaker in most of national and international conference in radiology and maternal-fetal imaging. My talk is addressed as a visibility study in assessment of congenital cardiovascular malformation by recent technique of fetal cardiac MRI. Now I will share my desktop. Share. Okay. Let's start my presentation now. Okay. As I said before, the title of my presentation, Visibility Study and Assessment of Congenital Cardiovascular Malformation by Recent Technique of Fetal Cardiac MRI. I'm a Dr. Hind Jalal, a Program Director of Radiology Program and Associate Professor of Diagnostic and Intervention Radiology at Ain Shams University. Before to start this essential topic, we have to know why we need to address the congenital heart disease. Why giving it the most importance? Why? Because we have to tell the mother her baby has a heart abnormality. It's a very stressful moment to telling the mother this important finding. Most common and most difficult fetal anomaly all over the baby is cardiac abnormality. It's 1 over 110 babies born with congenital heart disease Also, 1.3 million children worldwide are born with congenital heart anomaly. Third of them need a life-saving treatment before age 1, and third of them have a major congenital anomaly. Also, the importance point, and 90% of them occur in pregnancy with no risk factors. So it's very important topic to talk with. I know this wonderful forum is linking any technology and any presentation with sustainable development. So this topic linked with many or few aligned with this SDGs. One of them is good health and well-being. SDG 3, as an early diagnosis, can lead to the better management and improving health outcome for both mother and the fetus. Also, SDG 4 with quality education as a fetal MRI is relevant to educate, and it is and supports the training of healthcare professionals in advanced imaging technique and prenatal diagnosis. So educating healthcare provide the interpretation of fetal MRI scans and their clinical implication, enhancing the quality of prenatal care. As well as SDG 9, industry innovation and infrastructure. Innovations of MRI technique contribute to building a sustainable infrastructure in healthcare system, improving diagnostic capabilities and patients' outcome, as well as produced inequalities because fetal MRI can be contribute to reducing inequality in healthcare. How would that do? Ensuring that a pregnant individual, regardless their socioeconomic status or geographic location, have access to accurate prenatal diagnosis, promote equality in the healthcare provision. Also, SDG 17's partnership for the goals, collaboration between healthcare institution, research organization, technology developer, and policy maker are essential for the advancement and dissemination of the fetal MRI technology. So let's start our main content. As we said, the most common congenital disease is a congenital heart disease, and first cause of infant mortality is a congenital heart disease. Of course, fetal echocardiography is a method of choice to visualize the fetal congenital cardiovascular abnormality. It's basically evaluated between 18 to 22 weeks of gestation and performed by the simplest transducer 2D color Doppler, and could be using 3 or 4D machines to assess anatomical assessment of the cardiac chambers, blood flow, cardiothoracic ratio, cardiac rhythm, and fetal heart rhythm. However, the limitation of fetal echocardiography could be a time-consuming, technical skill, and dependent on a user or experience of the user. And there is a limitation regarding the maternal limitation. If a mother was very obese, if have a uterine myoma, if has a scar of previous pelvic surgery, it could be a limitation. Also, fetal limitation as it's twins or triplets, oligohydramnios, polyhydramnios, fetal position abnormality, or rib calcification. So we're introducing a new technique or adjuvant technique, which is a fetal cardiac MRI, giving its advantages about that overcome the limitations. There is no limitation in maternal obesity, no limitations in twins or oligohydramnios. Also, it's adding an additional information in fetal cardiac tumors, heart, diverticular, pericardial cyst, and pericardial effusion. Also, without doubt, it can detect all the extracardiac abnormality. So our aim of the work is to highlight the advantage of MRI over fetal echocardiography and assessment of fetal congenital cardiac in assessment of fetal cardiac abnormality. So our study was occurred in 2 years duration. It was a cross-sectional study done in many sources, like a fetal care unit in Ain Shams University and Cairo University was the partial source of the cases, and the study conducted in radiology department of Ain Shams University. Study population include all pregnant female suspected or diagnosed with fetal congenital cardiac abnormality using a routine antenatal care, and excluding cases with maternal claustrophobic or mother with cardiac valve disease itself. This study was covering 52 pregnant female and their feti. There is no specific preparation for the patients. We're doing an obstetric ultrasound and fetal echo examination, as we said, to see all the maternal fetal biometry and fetal Doppler. Also, the basic and detailed fetal echocardiography has been done. Then fetal MRI occurred at 24 to 39 weeks gestation, putting the mother either in supine position or lateral decubitus, whatever she can tolerate. She can perform, the MRI can be performed with a 1.5 Tesla superconducting magnet using a very simple superficial coil, no maternal, no fetal sedation, and no gadolinium injection. Controlled maternal breathing was used, and the overall mean time for this examination was 30 minutes. This diagram could see how the picture is occurred, how the sequence are taken from the previous section. All these sequences or this picture could be introducing to you how visualizing the fetus heart is occurred either in systole or diastole, how the function of the heart could be detected and could be measured in this sequence. After doing both fetal echo and fetal MRI, we can interpret the image either by anatomical segmental approach in echocardiography or modified segmental approach in MRI after detection of visceroatrial situs, cardiac position, size, X's, and chambers. After that, we're starting to know the ventricular looping, either D loop or L loop, inflow vein, outflow vessels, ventricular arterial concordance, or sinus of aortic arch. So after finish taking the values, we can get a statistical result in which the maternal age, mean maternal age was 30.4 years, gestational age was 30.8 weeks, gestational age at the delivery was 36.5 weeks. For fetal biometry and umbilical artery Doppler, we can see how the means value of all these parameters. Regarding the gender of the baby, the male gender and female genders, male gender was more predominant, presentation cephalic was more predominant, and amniotic fluid index were normal in about 73.1%. Umbilical cord was normal in most of the cases. However, there is intrauterine fetal death occur for 1/3 of the cases. Important history parameters in this case was a consanguinity was in 42.3%, previous history of anomaly in 30%, and high-risk disease like diabetes, gestational diabetes, and hypertension in 11.5%. In agreements between fetal echo and MRI was a significant moderate agreement in 50% and 50%. With comparing to the gold standard postnatal echo, can see that the fetal echo is keeping with postnatal echo in 86.4%, and MRI was more linked or more postly accurate than the fetal echo. It gives 95.5%. As well as we said, an extra cardiac anomaly, all are detected by fetal MRI. So to conclude our study, we can see that MRI as an adjunct to fetal echocardiography may provide valuable information that could add to the prenatal diagnosis and evaluation of cardiac and most of extracardiac anomaly. And this study has been published recently in Egyptian Journal of Radiology and Nuclear Medicine. And finally, this point could be linked in our brain. If the heart beats, it doesn't mean that it's okay. It's maybe in a great pain. Thank you. Can stop share.
Thank you.
Please return to the main view of the conference.
Does it work?
Yes.
Okay, perfect. Thank you. Should we move on?
Thank you for our audience. And if there is any questions, I'm welcoming to hear it, and probably I answer it. If there is any question for any audience.
For the questions, you can leave your questions in the chat or the sector questions and answers, and we will have some time at the end of the session to discuss all of them.
Great, great. Okay, let's go to the next speaker. I would introduce, and joining us nextly is Dr. Kulika Abikon. Is a senior lecturer of mechanical engineering, Faculty of Engineering, University of Morituwa, Sri Lanka. She has a medical philosophy in Department of Industrial Management, University of Kelania, Sri Lanka, senior lecturer for more than 23 years of academic lecture experience and 5 years in industrial engineering experience, with her passionate advocate of leveraging technology to improve women in healthcare with a wealth of experience in research. Her research aiming is employment of people with a physical disability, ergonomics, industrial engineering, and human-machine interaction, and as well as textile and apparel engineering. She has an impactful initiatives that have improved access to quality healthcare service for women worldwide. Her insights and visions for a future of women health make the presentation a must attend for all. Her presentation title is The Validation of Residual Physical Capability of Women with Physical Disability in Their Shoulder-Arm Region for Employment Support using the WARM map tool. Go, Dr. Kulika.
Am I share the presentation? Can you hear me, ma'am?
Sure, we can hear you. You can share the presentation.
Good afternoon. I'm Dr. Kosila Madhuri Jevisumabekun from Sri Lanka. This research is on the validation of form framework, which has been done for employment support for people with physical disabilities. This is the part of the research that I have been carried out. The title is The Validation of Residual Physical Capability of Women with Physical Disabilities in Shoulder-Arm Regions. Co-authors are Dr. Iman Kulsheva and Dr. Julian Nanakare, both are the mechanical engineers from University of Morituwa, Sri Lanka. I will introduce the background for this research, and then I explain an objective, the methodology, why I have used a range of movements in this study, and why not ranges of motion, and the protocol used for ethical clearance and scientific evaluation, and the study to validate the warm method for shoulder-arm regions. Then the results will be explained again, affected range of motions of shoulder-arm region, the residual capabilities of the people with these deformities and their work abilities. And finally, the contribution to knowledge. There are different kinds of people with different disabilities. In this research, it was considered only people with physical disabilities which have mobile deformities. And warm map is a novel philosophical tool which have been developed for work activities, considering the work activities that need to perform the range of motion for typical manual work activities. Using the typical manual work activities were taken from the MTM1, that is method time measurement, and method time measurement 2, which are predetermined motion science systems. In the perspectives of the stakeholders, the women with physical disabilities perspective, they have the task performing abilities, but they found difficulties to enter industry because with their difficulties, nobody knows about what they can perform. And also they have a fear of required essential facilities at work. In employer's perspective, they don't know what are the capacities or the capabilities of women with physical disabilities. And though they recruited people, they don't know the success or failure of recruitment. And they can't find the suitable job opportunities by interviewing them in the proper interviews. In the government perspective, it is a social responsibility employment there, but they don't know that the government knows that the underuse of potential of these people is a waste, and they can earn significantly good amount, but at the moment it's not. And women with physical disabilities are unable to find employment, the suitable employment for them, making them non or underproductive. So the aim of the research was to identify residual physical capabilities of women with physical disabilities in their shoulder arm region using the WARM map. The objectives were to screen women with only physical disabilities in their working age, that is 18 to 55, and prepared relevant data collection formats, political coherence and scientific evaluation, awareness, consent, demographics and data collection, and the consent for participation in the study. And finally, they carried out studies to validate the WARM map. And there, it was done the affected range of motion of shoulder arm region and limitations of typical manual work activities. Finally, the residual capabilities and work abilities were found. There are different kinds of instruments used for measuring the capabilities and the strength of people. While the ROM wide range of movement has been used here, but not range of movement. The range of motion is defined for a joint, such as ROM of a shoulder joint, some of a elbow joint, some of an ankle, like that. But work is usually performed by a body region as well as a combination of joints. Therefore, ROM alone can't be used to assess the movement of the body. Thus, instead of ROM of a single joint, range of movement of body regions or joints were studied to identify residual capabilities of women with physical disabilities. In the initial stage, there have been 3 studies carried out in 5 phases. Usually, the work activities were identified by industrial engineers, professional engineers, using this MTM1 and MTM2. Thereafter, the range of movement or RM was found out using the medical experts and identified human body regions and joints used for performing these work activities. Then the WARM map was done with the help of orthopedic medical experts, N equals 2, and they, using this range of movement, they identified the range of movements which are necessary to perform typical manual work activities in the industry. Then finally, the usability study was conducted with a sample of 22 participants, and the functional D analysis was found out with the 92 participants. Then out of these 92, there have been 7 women with shoulder arm deformities. They could only perform internal and external rotations. When these are the typical motions in the upper extremity that has been carried out, typical manual work activities, that is reached in the picture I have shown. That's when we extend our arm, full arm, it is the reach maximum in the horizontal plane, and the reach minimum is if we keep our elbow to the body and move our fingers like this. Then the other activities identified are like this. And grip classification, grip activities are again classified to identify to make better performance at the industry level. Then non-grip, power and precision grip, and precision grip. And then these are the range of movements of human body in the upper extremity. And here I have considered only the shoulder, arm, a range of movements of women with physical disabilities. These are flexion, extension, abduction, adduction, internal rotation, external rotation, and circumvention. This research was the validation was done for these people only has internal and external rotation. It's also a mild abilities that they are with these people. And this is the part of the warm map which have been carried out. According to this warm map, when here comes the body region, and then next the ranges of movement, and here the work activities. Though the person can perform internal rotations and external rotations, they are able to perform the activities which are being marked in green color. Then with that, the operators can, these people, these women with shoulder arm deformities or difficulties can perform fingertip, pinch grip, heel grip, complex, and toe grip, and regrasp. With that, this validation was done. And there have been 7 people, and all the people all the women have left hand, their both left and right have affected badly. And therefore, they could not perform any, these I have marked as 0. Though they have these deformities, they can perform some kind of work which have been identified as disabilities, and these are the work limitations. In conclusion, the ethical clearance was granted from Medical Research Institute of Sri Lanka, and the warm work activities, which is a part of the warm, and the range of movements, the colors, framework was developed using principles of ergonomics to help people effectively perform in industry. Out of the 7 women with physical disabilities had deformities in the arm regions, and they could slightly rotate the internal and external shoulder arm out of 92 study participants. Then the residual work capabilities were identified. With that, their residual capabilities, they can perform operations such as hand swing, hand embroidery, computer data entry, and painting. With the warm map framework, women with physical disabilities, with their residual physical capabilities of women, can perform lowest elementary levels of typical manual work activities. So that I would like to say that warm map framework is a bridge which makes differently able people for useful employment. And I would like to add my sincere thanks to Mr. Anand Peter. Thank you very much.
Thank you, Dr. Kukila, for your interesting topic. Thank you for your presentation. Is Dr. Lariu Malinguana here?
Hello. Yeah.
No. Or
Okay, I'm just showing that you are here. Okay, our third presenter is Dr. Lariu Malinguana, researcher at the University of South Africa, bring a unique perspective to the intersection of technology and health. Lariu's research area is primarily on the use of adoption of information technology in public healthcare. Her presentation topic is talking about enhancing patient documentation and optimizing medical operations thanks to wearable gadgets. Let's start, Dr. Lariu.
I think she's not here, so maybe we could move to the next speaker.
Okay, our next speaker is Professor Dr. Afshin Arif. Okay, are you here, Professor Dr. Afshin?
Yes, I am here. Can you hear me?
Okay, we are honored to have Dr. Afshin Arif with us today. It is an assistant professor in the Karachi Institute of Biotechnology and Genetic Engineering, University of Karachi, Pakistan. She is an expert in working in a rare and congenital pediatric disorder, which is, of course, it's an interesting topic for me. Okay, she has over groundbreaking research for more than 40 publications in esteemed international journals. She has been a key resource person in multiple committees, focal person like quality assurance, quality enhancement cell, office of research, innovations, and commercialization of the institute. Her experts and dedication to advancing women health through technology make her valuable additions to our conference, of course, Dr. Afshin. Your talk is talking about congenital septal defect in Karachi, Pakistan, an update of mutational screening by high-resolution multi-analysis of MTHFR. Go on, Dr. Afshin.
Thank you very much. Can you please see my slides?
Yes.
That okay? I'm Dr. Afshin Arif, assistant professor at University of Karachi, and I've been working in the field of congenital rare genetic disorders from last 25 years. I'm really honored for this platform for giving me opportunity to discuss my recent research, which is upon high resolution melting HRM genotyping of MTHFR C677T in congenital septal defects patients in Pakistan. So we will go through this the content of the presentation. Congenital heart diseases are the defects in the heart, which are from the inbirth from patients in the patients. And it is one of the most leading non-infectious causes of the disease and mortality in children under the age of 5. And it is approximately about 1% of the patient of the global children who are suffering from these diseases. It is about 11% in Southeast Asia, and 10 to 12 per life births in the global contacts. 9 point this map shows the different prevalences of the congenital heart diseases in different population of the world. While in Pakistan the condition is like about 3.4 in every 1,000 live births suffering from congenital heart defects, and it includes about 60,000 babies, where Karachi is the highly populated and metropolitan city of the country, and about 60% died in under the age of 10 years. So we were screening. First, let me discuss something about congenital heart diseases. There are two types. There are cyanotic disorders, which comprises of tetralogy of palate, trichoepithelioma, single ventricular and double outlet right and left ventricle, and transposition of great arteries. And there are acyanotic, where the blood circulation not much stuff, like atrial septal defect, ventral septal defects, and pulmonary valve and long QT syndromes, and patent ductus arteriosus. So we focus on these three defects, and the distribution of congenital defects in cardiac anomalies are like this in the documented literature. So just let me give you a brief description about what are atrial septal defects. As we all know, there are 4 chambers of heart. So this is the hole or a malformation between the two atria of the heart. And there are different types of ASDs, which I'm not going to go into details of them. We have ESD, which is ventricular septal defect, which is again an aperture or a hole between the two ventriculars of the heart. And again, there are several subtypes of these diseases. And then the AVSD, which is the most complicated one, is the one aperture between all 4 chambers. And we have complete, intermediate, transition, and partial AVSDs, depending upon the genetic makeup of a child. The diagnosis goes through the cardiac murmurs, pulse oximetry, chest X-ray, ECGs, and echocardiography, and cardiac catheterization, cardiac MRI. The risk factors could be maternal diabetes, maternal obesity, phenylketonuria, maternal alcoholism, living at a high altitudes, some viral infections, chromosomal aberrations, or genetic variations. So we focus mainly on gene variations. These genes are the gene we focus is on comprises of 12 exons and 11 introns, 21.1 kb, and 656 amino acids with 74.5 kilodaltons. It is an exon 4, converting alanine to valine with a point mutation from GCC to GTC. This is the pathway is the folic acid pathway, which is mainly involved in methylene THF to convert methyl tetrafolate. With this single mutation from TT to CT, homozygous to heterozygous, the reduction of the enzyme is 50 to 70%. So the present detecting technologies which are available could be PCR RFLP, indel PCR, which is insertion deletion arm PCR, and a sequencing. But we focus mainly on high resolution melting to check these mutations through this new technique. The features are, it is PCR based, it has no post-PCR techniques, it is a single tube closed system, it needs only HRM software, length and composition of the GC contents. So mainly what happens in HRM, amplification of a gene and the binding of the dye. So the intercalating dye bind with the DNA and it gives a fluorescence. And while the dissociation from the double-stranded to the single-stranded DNA, we can detect as per the linearization of the DNA molecule, we can detect the dye with the help of the software, so that we can see where the mutation arises. I'll be in detail of this method to identify the association of. This was our main game main goal to establish high resolution HRM as an alternative technique for screening the mutation and to identify the association of this variant with the several defects and to find out what are the genotypic and phenotypic relationship of ASD, VSD, and AVSDs. So the methodology was we collected the samples, DNA extraction, and then we do the mutational screening through all three methods which were available for comparison. We took the ethical approval from IRB of our institute and from NICVD, which is the National Institute of Cardiovascular Diseases, one of the main public sector hospital in the city. This is the consent form. The sample size formula was calculated accordingly. And we collected 50 ASD patients, 50 VSD patients, and 50 AVSD patients with 50 controls. So the study comprises of 200 individuals. The inclusion criteria was diagnosis through echocardiography, less than 15 years of age, non-syndromic and non-familiar cases were selected, healthy controls and normal echo controls. And the echo was also done for the patient because sometimes at the age of 45, at the higher ages, the patient comes to know about the ASD defect. So we had done echo with all the normals and all the patients of us. DNA was extracted through sorting out method. Cell lysis buffer was added, and then washing the pallets and then sorting out the DNA with NaCl method. Precipitation was done. Quality was checked through nanodrop. Across electrophoresis, PCR RFLP was done through the safe primers, and this was the reaction mix, and that's how we detect the PCR RFLP with the restriction enzyme HEMP1, and we got this type of a genotypic composition on the gel, where we have CC genotype with 300 base pairs, TT genotype at 200 and 100 base pairs, and CT genotype with these three bands. We did the sequencing also, so that we will be sure that whether what we are getting the results from the HRM aligns with the gold standard method of sequencing. And then we did the high resolution bundling. This is the primers were designed only for the 45 base pair. And this was the reaction mix, which was done with the super mix. And these are the optimized conditions for the reaction. PCR primer specificity and sequence alignment was done with BLAST, MEGA. And the statistical analysis was done by SPSS and other softwares. So this was the gender distribution of our patients. 15% ASD, 19% male and female, and age distribution among the patient group, 39% and 40%. Weight distribution, defect, septal defect subtyping of the patients, and then and the complete AVASD and 13%. Frequencies of ethnic groups of different population in our sample cohort. And we noticed that there was a high rate of tobacco consumption among the parents, may be one of the risk factors in our population for these diseases. This is the PCR RFLP results, with, as I told you, about the 282 base pair size of the band before restriction size, and then we get this after the digestion with the HEMP enzyme. These are the sequencing results where you can see the change of a single mutation. And this is the heterozygous mutation. And when we optimize the real time, we started with the two-step amplification, which was giving not so good results, but with the three-step method, we acquire the desired kind of results with the melting curve. And then we go look into for the cooling effect, and then we go for the temperature increments to optimize it with the magnesium chloride. And these are the different concentrations of the magnesium chloride reaction. And then these are the samples that we have incorporated: ASD samples, VSD samples, and AVSD samples. So this is this can be done. The multiple samples can be done at a time. After that, the genotypic frequencies were analyzed in our patients, and this is how you get a curve of homozygous and a heterozygous. There are CC genotype is 74% and 85% in the cases and controls, while the homozygous CT was 26% in cases and 14% in controls. While it was very amazing to see that there is no TT genotype in our population. And we'll then look into the different populations of the world where we can see also this TT genotype, but this is kind of a maybe a lethal mutation which is not occurring in the population. So you can see the graph where we can see that there's a heterozygous genotype in the case groups than in the controls. And we established this odds ratio for the diseases. So the conclusion is that MTHFR 677C2T mutations, which has an RSID of 1801133, was found to be associated with the congenital septal defects. Phenotypic relationship showed that mutant T allele was associated to increase the risk of ASD than the other septal defects, and HRM analysis was successfully established for genotyping of the known SNP of this disease with the confirmation of sequencing and PCR field results. Future perspectives could be homocysteine levels in plasma should be used to check in the CSD patients. Parental tobacco consumption and its role in the CSD should be well studied. Recently, this has been published in Human Genomics BMC journal, and these are the references. And this is our team who has worked for this diseases. These are the specific team members, and thank you very much for giving me the opportunity.
Thank you, Dr. Ashin. It's a very interesting topic. Really amazing presentation. Thank you for your time and your efforts.
Thank you very much for giving us the opportunity.
I inform Professor Dr. Merfat Fouda and Dr. Lariou are not present. So this time for mutual questions. If there is any of the audience or speakers have questions for any speakers, we are welcoming to see how to listen to the questions and answering this. We have a lot of penalty all the time. Maybe I have a small question to Professor Dr. Afshin. As I told before, this topic is also my specification or my specialized department. I mainly congenital heart disease, but maybe I maybe found it in fetal life or prenatal screening time. So how can we link your finding or conclusion to find this mutational gene to be tested either in mother during the pregnancy, or it could be just you need a sample from baby, a blood from the affected child, or could be a screening test in a fetal life.
Yeah, this could be an area which can be developed, and it has been the people are working but I was also in collaboration with them at NIFT, non-invasive fetal technology, NIFT. So they took the sample from the mother, but there are some traces of the fetal blood as well. fetal cells also. So we can check this kind of a mutation in the fetal cells while taking those samples, which are non-invasive fetal techniques. So if we get the issue or the modification which they are trying to do is there are very less number of fetal cells in that sample. So we need more fetal samples to enhance, and then we can screen such mutations in the fetal sample also.
And what kind of inheritance for these mutations? Either it's a dominant inheritance or yeah, how the percentage, if a mother have a baby with ASD, AFSD or VSD for once, what the percentage to get another baby with the same abnormality again? The mode of
So
inheritance,
that
either
could be
dominant or recessive.
that could be about what we have seen in our example cohort is about the lethal genotype, which is TT, was by natural selection, was not in the society, was not in the group. That means if there is a TT genotype in a fetal, it is not surviving. So with this, the T allele is reduced in the population, and it has not been transmitting more and cutting down in the cohort and in the population as well. We need to look a little bit more to follow up this thing, how it is going on. This was a little bit surprising for us also. While
Yes.
in other populations like Western population, this TT allele was there in their population, but it was not in Asian population.
Okay. Thank you for the clarification. Thank you.
We can collaborate on this.
Yes, sure.
Thank you very much.
If there is any more questions before closing this session?
For now, there are no questions in the chat. I would also like to thank you for your fruitful conference and insights. And if there are no questions, we can close the session.
Thank you, Tanya. Now go to the closing sessions. We can conclude this scientific and wonderful talks to express my heartfelt gratitude to each of you for your invaluable contribution, insights, discussions, and dedication in advancing of intersection of technology and health in women empowering. Thank you once again for your participations and dedication. I look forward to seeing a positive outcome of our collective efforts in these days ahead. Thank you, all of you.
Thank you.